Dear students, today's topic is series LCR circuit phasor solution. We are going to solve this circuit with the help of the phasor diagram. There is one more solution which is called analytical solution, which we will be dealing later on. So the name series LCR may be written in different ways like LRC and so on, but do not confuse, okay? So all are same. In the last lessons we applied AC voltage to the different elements like capacitor, inductor and resistor separately. But here we take these in series and we apply AC voltage. So therefore the name has come series LCR. So let us consider this diagram. At particular instant of time, let the direction of current is given as given in this diagram. So in this circuit, this is the current I, this is also current I, this is also current I. It means that there is no change in the current. Yes, there is no change in the current because this is in series, and we know that in series the current remain same. Okay, so this is the resistance and R is the resistance of this resistor, which is V by I, and the unit of this resistance is ohm. And this is inductor, and the resistance offered by this inductor is XL, which is named as inductive reactance, which is equal to omega L. Omega is angular frequency of the voltage or current, L is the inductance, okay, of this inductor. Well, the capacitance, for the capacitor we have got XC, which is the resistance offered by capacitor, known as capacitive reactance, which is 1 by omega C. We have all derived this. What will be the unit of XL and XC? The unit of for XL and XC will be ohm only, because they are resistance to the flow of current. Okay, so the current are same. Now let us draw the phasor diagram for resistor. Okay, so first let us draw this as current I. Here also I will draw I. Why I am drawing I will tell you shortly. Okay, so since the magnitude of the current for all these elements are same, therefore I am writing I and I am writing I. I am not writing current through the resistance, current through the inductor, current through the capacitor. I am not writing IR, IC and IL, because the current is same, because they are in series. So in resistance, what happens is that there is no phase difference between current and the voltage. If there is no phase difference, then the voltage vector and the current vector in phasor diagram lie in the same line, right? So the voltage will be here. This is V for R. Now in the inductor, now what happens in the inductor is that the current lags the voltage, that is, or the voltage leads the current, both are same. Current lags means current is behind, current is below, current is behind the voltage. If the current is behind the voltage, then voltage is ahead of the current, voltage is leading the current. If the voltage is leading, where should be the phasor diagram for voltage? So if this is current, then voltage will lead means it will be here, okay, it will be here. So this is the voltage through the inductor. So this is pi by 2. Okay, it will be lagging or leading by pi by 2. What happens in the capacitor? In capacitor, current leads the voltage or voltage lags the current. Okay, if the voltage lags the current, or if the current leads the voltage, then voltage should be behind the current, because current is leading. If it is current is leading, then the voltage will be here, that is V across C, right? Now if you see, the length of the VL is longer than the length of the VC. It is because in this situation voltage is leading, which is ahead, and in this situation voltage is lagging, which is behind, so it is smaller than this one. So let us make the phasor diagram for entire LCR series. So I will write it here, phasor diagram, okay, because we are solving with the phasor diagram solution. What is there? What is there? there is the current I, and there is voltage V, and this is my V of R, and this is my V of L, and from here we have this as the V of C. So this is the phasor diagram for series LCR. Now if we see here, there is one arrow going up, say it is 10 Newton force. From the same point, there is one arrow which is going downwards, say 5 Newton force. Okay, so which will win here? This 10 Newton will win because this is smaller. Okay, and in which direction the net force will act? It is pulling up, it is pulling down. The net force will be in upward direction because this is small. How much will be the force? The force will be in this direction. The net force will be in this direction because this will win. And how much will be this? This will be 5 Newton. Why 5 Newton? Because 10 minus 5 Newton will give me 5 Newton. Similarly, this VL is larger than VC, as we have already studied. Then what will happen is this will win as this one. So there will be VL minus VC vector somewhere here, isn't it? So let me draw this here now. Okay, so to draw this, I will have this kind of thing here. So this is okay. Let me draw a little bit longer. I, and I is common, so there is no IR, no IC, etc. So this is VR, and the E is this vector, which is VL minus VC, isn't it? Like this one, because this is large, this is small, and opposite. So these two are the vectors now. Now how to find the net vector, net voltage of this? I will write it here. This is say VR. So to add this vector, one is VR vector and another is VL minus VC vector. We have to use the vector addition law, that is parallelogram law of vector addition. So to do so, let us draw it, make a parallelogram right here, just right here, and this will be giving me the net voltage V. Okay, that is the total voltage, and this V is making some angle with this current I, isn't it? So this is the current I, and this is the net voltage which is making certain angle. Let me write this as phi. Okay, where this phi is phase constant. What is it? It is phase constant of series LCR. Okay, which we are going to study in couple of time. So this is done. Now this is a right angle triangle. Can you see it? This is a right angle triangle. Now using the properties of right angle triangle or the Pythagoras theorem, what happens is the hypotenuse is square. This is hypotenuse, that is V. Square will be base is square. What is this? Base, that is VR square, plus perpendicular square. So this is equal to this one, isn't it? This is same as this. So this is my VL minus of VC. So plus VL minus of VC whole square. So Pythagoras theorem से आ गया ये. तो अब हमें क्या करना है? Let us remove this V square. If I remove this V square, then I get V, which will be equal to under root of VR square plus VL minus VC whole square. So this is the equation of voltage. Okay. So what are VR, what are VL, and what are VC? Let us put the values of VR, let us put the value of VL, let us put the value of VC, and find one more equation. Okay, we are going to use the same equation here. So again, what we know is, we know V is equal to IR. Okay, using this, if it is VR, then this will be IR. Okay, and what will be the V of L? It will be I into R is the resistance, isn't it? And what is the resistance offered by inductor? The resistance offered by inductor is XL. So I will write XL here, and I will write VC. So it will be I into XC. Okay, XL is the resistance and X is the resistance of the capacitor and inductor. I is same because I is the current. So if I put it here, I should be getting this V is equal to under root. What are the quantities? VR square will be I square R square, I square R square, because there is VR square, plus then VL is my I XL minus VC is my I XC and whole square. So this is our equation. Now in the next step, what we get is that I will take under root, this is I square R square plus this is I, this is also I. If I take the common and if I take them outside this bracket, then what is there? Because of this square, it will be I square, then it will become XL minus XC. Fine? Okay. So let us go up here and solve it further. Now what is there? This is I square, this is also I square. If I take common and if I take outside of this root, then it will become what? It will become I square will come out as I, and this is equal to R square plus XL minus of XC whole square, and implies this, it will become V by I is equal to under root R square plus same XL minus of XC whole square. Now can you tell me what is V by I? What is V by I? V by I is resistance, isn't it? V by I, if you see, V by I is resistance. But this V by I is the resistance of entire circuit. Please remember, this V by I is the resistance offered by this entire circuit, isn't it? So this V by I is called impedance of this series LCR. Okay, because impedance, what is the meaning of impedance? Impedes means to slow down, okay, to push it back, to give obstacles. So impedes means the resistance. Okay, so this will be equal to Z is equal to root over, what is there then? R square. Now it has become very simple, XL minus of XC, where Z is equal to V by I, or this Z can be written as V0 by I0. That is very simple. Z is equal to V by I. Capital V and capital I is from the Phasor diagram, and V0 by Vi are the maximum amplitudes or the peak values of voltage and the current, that is from the analytical solution. And Z is the impedance. What is it? Impedance. Impedance of the circuit. Okay, or LCR series circuit, we can also say that one. So what will be the SI unit of impedance? What is this impedance? Is the resistance offered by LCR, series LCR circuit. This Z is the resistance offered by series LCR circuit. Now if it is the resistance, then what will be its SI unit? Its SI unit will be again ohm. Okay, the SI unit of Z is ohm. That is fine. Now we had talked about the phi, which is phase constant of series LCR. So let us talk about the phase constant in the next lesson. So we are going to study some more things about series LCR. For an example, if I am applying the AC voltage which is having omega, that is angular frequency, okay, and this voltage or this current will oscillate in this circuit with certain frequency, which is called as natural frequency. And from there we are going to study the resonance in series LCR. Okay, and this series LCR is also known as tuning circuit. In fact, this series LCR is used in the radio, okay, to capture the signals. That is later part. Next is that what will happen if XL is equal to XC. Okay, what will happen if FR is 0? All these things we are going to study in the couple of lessons. Okay, sometime this entire circuit will act like a capacitive circuit. Capacitive means as if there is only capacitor, though there are resistor and inductor, but it will act like a capacitive circuit. And sometime it will act like a inductive circuit, as if there is only inductor, though there are capacitor and resistor. Okay, all these things we are going to study in the next lesson. Thank you.